Video, we're going to be covering finding the tangent line, velocity, and acceleration. So we're going to go ahead and get started with looking for a tangent line approximation. Now we need to find this tangent line approximation for f of x equals 1 plus sine of x at the point given, which is 0, 2. The first thing we need to do is find the derivatives. The derivative of 1 plus sine of x would give us f prime would be cosine of x. So having this derivative, now we have to calculate the line using this formula. When we plug in a 0 into this function, our answer is 1. Also, when we plug in a 0 into this function, our answer is 1. So then we take care of distributing. So it's just 1x. We must add this 1. So we find out that the answer is y equals x plus 1. Or y equals 1 plus x. Either way would be fine. Now we need to go ahead and calculate using the table so we could see what would that point be. So using your calculator, and I'm using mine over here on the side, we have to compare the values between the function and the tangent line. So the function is f of x 1 plus sine of x. The tangent line is the bottom one, which is y equals 1 plus x. So when we have the value that x is 0.05, negative 0.05, the function gives me this value, 0.521. The tangent gives me a 0.5. With the negative 0.1, I get a 0.9002. Down here, I get a 0.9. When we have a negative 0.0001, I get 0.990002. This one would give me a 0.99. Now these numbers are approximating something. When it's 0, it's 1. Both of them give you a 1. When you have a positive 0.01, I get a 1.0099998. This is a 1.01. When it's a 0.01, when it's just a 0.1, I have a 1.0998 and a 1.1. And the last point that we're trying is a 0.5, 1.479 and a 1.5. So when we look at all these points together, we could see that when x is 0, that's when they touch each other. So the closer the number to the 0 on both ways, either from the positive or negative end, the closer the answers, these numbers, are to a positive one. If we were just to do a little sketch here, nothing perfect, but let's say that this is pi over 2. This is negative pi over 2. We'll say this is 1. And this is 2. This is negative 1. And this would be a negative 2. So as you're looking at the graph, the one for 1 plus sine of x, the point goes from here somewhat like this. Now, when we graph 1 plus x, that line, well, not like that, but a little bit nicer. It only touches it at 0, 1. So in the next part of the video, we're going to let s of t be a function given the position of an object at t time. So we're going to be talking about velocity, speed, and acceleration. So first we need to understand what each of these things do and how do we find them. So to find the velocity, we are looking for the velocity. Since they give us s of t, we need to make sure we take the derivative of it. Speed is the absolute value of the velocity. So once we do velocity, we could find the speed. Now, the acceleration, that one is basically the main function they give you, which is s of t, when we take the, not just the first, but also the second derivative. So we're going to go ahead and do an example with velocity and one with an acceleration in a little bit. So continuing on to the velocity, it says, a ball is thrown straight upward from a ground with the initial velocity of, and that's what the v sub 0 means, initial, 96 feet per second. The height of the ball at time t is given by the position function. S of t equals negative 16t squared plus 96t. Now the first thing we're trying to find is the maximum height attained. In order to do that, the first thing that we need to do is go ahead and find a velocity. Now, in order to find the velocity, remember, according to the notes up here, we need to take the derivative of the function that's given to us. So when I am looking for s, the derivative of it, this becomes negative 32t plus 96. Not only do I need to do that, but I also need to set this equal to 0. When I do that, we subtract 96 from both sides. So I get negative 32t equals negative 96. We divide both sides by negative 32. So then we get that t equals a positive 96 over 32, which really equals 3 seconds. So because we're talking about time, time is in seconds. So at 3 seconds, that's when the ball is at the maximum height. But in order to find out the maximum height, we need to go ahead and plug in this 3 back into the given formula. So I have s of 3 equals negative 16 squared plus 96 times 3. As we calculate this, we find out that this is a negative 144 plus 288, which gives me that at 3 seconds, the answer is a positive 144. So the maximum height is 144 feet at 3 seconds. So having this in mind, we're going to go ahead and move on to the next section, where it says, please find the velocity in which the ball hits the ground upon its return. So the ball hits the ground when s of t is equal to 0. Well, in that case, let's just go look at s of t, which was negative 16t squared plus 96t. When I look at this, we need to see that what we could factor out is a negative 16t from both. So when I factor out a negative 16t from here, I have t minus 6 left over. But when I set these equal to 0, negative 16t is equal to 0, and t minus 6 is equal to 0, t here is 0, and t here would be a positive 6. So this would be the start time, and this would be when the ball hits the floor. So since we want to know the velocity when it hits the floor, we need to go ahead and use and think about when t is 6. So having the velocity formula, which we already figured out in the upper section, which was negative 32t plus 96. We're going to go ahead and plug in the 6. When we do that, we get a negative 182 plus 96, which tells me that at 6 seconds, I have a negative 96 feet per second. So let's look at this for a second. So when we see this being negative, we need to think about this ball that's being thrown up and down. The slope of this part is negative. So that's why the velocity comes out to be negative. So that's the only reason there. Now, continuing on to the last part, how much time passed before the ball returned to the ground? Well, as we have mentioned before, it took 6 seconds for it to hit the ground. But it travels 3 seconds up and 3 seconds down. So because the whole trajectory of the ball was from 0 to 6 seconds, and we said that at 3, that's when it reached its max. And I'm going to go off the graph here a little bit, but let's say this is the highest, and this, if we were to graph it, would be the 144. So the ball goes up, it reaches 144, and then it takes 3 seconds to come down. And keep in mind, this would be the symmetry of your graph. So continuing on to the problem of acceleration, let's go ahead and read this problem. Because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. The position function of each of these falling objects was given by S of t equals negative 0.81 t squared plus 2, where S of t is the height in meters and t is the time in seconds. What is the ratio of the Earth's gravitational force to the moon's? Well, in order to find the acceleration, the first thing we need to do is take the derivative. So let's start off just by saying what we know. S of t equals negative 0.81 t squared plus 2. Excuse me, sorry, that should be a t squared plus 2. So this is the position function. That's what we know it as position function. When we take the derivative of this, which would be S prime of t equals negative 1.62 t, this here is your velocity function. then when we take the second derivative, so s prime prime, that's just a negative 1.62. And this is your acceleration. So this tells us that the acceleration due to the gravity on the moon is negative 1.62 meters per second because the acceleration due to gravity on the earth is a negative 9.8 meters per second, we could go ahead and calculate the earth gravitational force to the moon. So in order to do that, we need to understand two things. What is the earth gravitational? So we have the earth's gravitational force over the moon's gravitational force. Well, the Earth gravitational is a negative 9.8, and the moon's is a negative 1.62, which gives us approximately 6.05. So this here is the ratio of the Earth gravitational force to the moon's, which is 6.05. So in today's video, we have covered how we could use a tangent line approximation, which we did in the first example. Then we did the velocity, which we had to take the first derivative and then calculate the times in which it would affect the scenario, which in this case was a ball, and the acceleration. So if you have any questions, please let me know by email about this video. Thank you so much for watching.